Hello, friends. Part two of your podcast on Section 6.2. So we're going to look at some problems applying those probability rules. First one here asks you to list sample space and give reasons why you said what you said. So are you right-handed or left-handed? Simple, straightforward question. All right, so the sample space is left and right because those are the only choices. You could make the argument for ambidextrous, but you still have a dominant hand. So if you were writing this on an AP exam, you would want to specify that. I actually think we did this in one of the two classes, but I don't remember which, so it doesn't hurt to go over it again. What is your height in centimeters? So we're looking for a reasonable number of centimeters from the shortest person you would expect to see to the tallest. So in the book, they use 150 and 200. And if you convert that, because 2.56 centimeters to an inch, you could convert that yourself and see that the upper and lower limits could vary, depending on how small or tall your population was. How much money are you carrying in your pocket? So what are reasonable values for that to take? The amount of coins, the worth of the coins in your pocket. So in the book, they pretty much leave it up to you to say whatever you want to say, but it clearly could go from 0 to whatever you think the most amount of change someone would have in their pocket. And I guess it's got to have a limit because it has a weight after a while, but they're just asking you to think about what are the reasonable values for a sample space. And the last one's interesting. How many minutes did you study yesterday, or it says last night? So it says that there's 1,440 minutes in one day. So if you spent the entire 24-hour period studying, you could have studied as much as 1,440 minutes, not more than that. Probably the actual number is closer to this round number here. Same deal in problem 6.54. Read these over. I'm going to give you a second to read them, and then I'm just going to show you the answers. Again, this is an example where just reading the question and reading the answer reinforces the concept you have to know for the test questions. So take a look at that. When you're ready, hit play, and I will pull this down. If any of these answers don't make sense to you, then those are questions you want to bring to class and try to get it worked out. This one's in your book. I'm not going to give you the answers here, but I will tell you that one of these does not make sense. You should be able to identify which one doesn't make sense and give a reason why that is. All right, this is the last one I'm going to do. They give you this problem, which you can pause and read from the Census Bureau. And these are the questions. Let A be the event that a randomly chosen American is Hispanic, and let B be the event that the person chosen is white. Verify that the table gives a legitimate assignment of probabilities. Well, from those rules, what has to be true? Well, all of them have to add up to 1, and every individual probability has to be between 0 and 1. And if you added this up, you would see that they do in fact add up to 1, and that all of each individual probability is between 0 and 1. What is the probability of A? All right, and we remember here from rule number 3 that if we have disjoint events like we have in this problem, then the way to find the solution to what is the probability being any of these is to just add them up. So if I add up this entire column, which is the event that the person is Hispanic, that probability adds up to 0.125. Okay, describe B, and it's got a C there. Remember, the C means complement, and that means the probability of something not happening. So, applied to this problem, the probability of B not happening would be 1 minus the sum of these two probabilities. So, because B is the probability that the person selected is white, so if I go 1 minus these two added up, that's going to be the complement of B. If you do it out, it comes out to 0.249. Almost out of time, so this last one is the probability of the complement of A, which means not this and this. So it's 0.691. We'll cover it in class. Have a good night.